Transformers have been pivotal in the success of deep learning, facilitating advancements across language modeling, vision, time series analysis, healthcare, and other domains. However, their quadratic time and space complexity hinders scalability to long sequences. To address this, recent research has explored subquadratic sequence models like MLP mixer, conf mixer, monarch mixer, and efficient attentions, each with its trade offs and limitations. Structured state space models or SSMs have also emerged as efficient alternatives with Mamba. Mamba is a selective SSM showing promising results in language modeling and inspiring adaptations in various domains. However, the lack of channel mixing in Mamba limits its effectiveness in modeling global information in multidimensional data. To overcome this, Mamba Mixer is introduced in this paper that incorporates dual selection across channels and tokens, enabling efficient mixing of information and enhancing information flow between layers. Mamba Mixer is applied to design Vision MambaMixer or VIM2, and we will see further details shortly, and also Time Series MambaMixer, which is also called as TSM2. This demonstrates competitive performance in vision tasks like ImageNet classification and object detection, as well as in the time series forecasting tasks. Now, if you look at this architecture, this primarily shows you the what exactly Mama Mixer is at a very high level. So as you can see here, despite the success of S6 in language modeling, employing them for non-causal or multi-dimensional data is challenging. Despite recent attempts to adapt S6 block and Mamba model to non-causal or multi-dimensional data, surprisingly, existing adaptations mostly focus on different scanning strategies and treat each channel separately, missing cross-channel dependency. To overcome this challenge and allow S6 block to select cross channels and tokens, that is where Mamba Mixer block helps. It has three main modules: selective token mixer, selective channel mixer, and weighted averaging of earlier features. The first module of Mamba Mixer is selective token mixer, as you can see on your screen on the left. This aims to mix and fuse information across tokens while having the ability of focus on or ignore particular tokens. Then we have selective channel mixer. In multi-dimensional data, learning the dependencies of feature is an important step towards training an effective and robust model. For example, it is known that images in different domains share cross-channel correlations while having domain-specific spatial correlations. In processing high-resolution images to avoid high computational cost, instead of explicitly modeling pairwise pixel interaction, one can fuse information across feature channels. In multivariate time series, features are different variates, and to take advantage of complementary information provided by different variates, learning their dependencies is required. Now, this is where this model MambaMixer helps a lot. If you look at the last pillar, which is weighted averaging of earlier features, this is simply inspired by DenseNet and DenseNet Former for all Maba mixer layers, as well as selective token and channel mixer blocks, and they directly connect the output of earlier blocks to their input using a weighted average mechanism. Now let's have a quick look at Vim2, the image one. This Vim2 is quite interesting. Previously, we were focusing on designing Mamba Mixer as a generic backbone that is able to selectively mix both tokens and channels. But in this diagram, we can see that we are treating it and modifying and using it to design a vision model. The original design of selective token mixer is suitable for causal tokens, while images are non-causal data and require model modification. On this diagram, you can see that the modification of Mamba Mixer block are adapting for the vision task. To adapt the primary design of MambaMixer for images, they have used cross scan presented by Liu, and in this scan, they have scanned each image in four directions: top left to bottom right to top left, top right to bottom left, and also bottom left to top right. And then each scan is passed to a S6 block, which is the selective SSM, and outputs are merged to form new embeddings. Now, just a very quick one on TSM2. So, TSM2 is for the time series modeling, and the overall architecture of TSM2 is also quite interesting. TSM2 first patchify each variant of time series separately and then uses a Mama mixer block with a unidirectional selective token mixer and a bidirectional selective channel variant mixer to selectively flow information and mix across both time and channel. The main reason for these choices is the causal nature of time dimension and non-causal nature of variant features. And I will drop the link to this paper in video's description. You can read further along. Just to summarize, what is happening here is in this paper that they have presented Mama Mixer block, which is a new SSM architecture with dual selection that efficiently and effectively selects and mixes information, informative tokens and channels in a data dependent manner, which allows connection across both channel and token dimensions. It also is demonstrating the ability and effectiveness of bidirectional S6 blocks to focus on or ignore particular channels using ablation studies. It is also enhancing information flow in multi-layer Mamba mixer based architectures by allowing direct access to earlier features by a weighted average mechanism. They are also presenting WIM2 and TSM2 models based on MambaMixer for vision and time series forecasting tasks with outstanding performance compared to baseline. That's it, guys. Really hats off to all of these researchers. Wonderful work, I should say. And MambaMixer and these state space models are really evolving and progressing at a fast speed, and good to see some alternates of transformer architectures. Let me know your thoughts in the comments. Also, I will drop the link to this paper in video's description. Go through it. If you are stuck somewhere or if there is anything you want me to clarify, feel free to put it in the comments. And if you like the content, please consider subscribing to the channel. And if you are already subscribed, then please do me a personal favor and share it among your network on social media and email, as that helps a lot. Thanks for watching.